Hello everyone, welcome to SQL Repository and you are watching part 3 of CxPacket and CxConsumer Wait. In the last two videos, we have discussed parallelism and also how cost threshold for parallelism impact the query plan. Now in this video, we are going to discuss when and why you will see CxPacket or CxConsumer Wait for your queries. So I believe you have already understood what are the producer threads, what are the consumer threads and what are the controller threads. If you don't know about it, I would recommend to watch the video on the parallelism first and then come back to this video. Okay, let's start and try to understand when and where we will see CxPacket wait type during query execution. So you have the controller thread which is not responsible for scanning any data, but this is responsible for the overall synchronization, and this controller thread will always show CxPacket wait. Now the producer threads, as you have multiple threads, and suppose if one of the thread has completed early and it is waiting for other threads to complete, it will also start showing CxPacket wait because it is waiting for other threads to complete, and until other threads will not complete, it will have to show CxPacket wait. Similarly, if one more child thread is complete and it is waiting for remaining threads to be completed, it will also start showing CxPacket wait. Same goes with the consumer thread. If any thread is completed and it is waiting for other threads to be complete, it will show CxPacket wait. And also, if it is waiting for the data to be available in the buffer, then also it will show CxPacket wait. And if the data is not available for buffer, it is responsibility of the producer thread to bring the data. If producer thread is lagging behind and it could not bring the data, then consumer thread cannot do anything and it will have to wait. And in that case, it will have to show CxPacket wait. But this was the behavior till SQL Server 2016 SP1 and SQL Server 2017 RTMCU2. But from 2016 SP2 and 2017 RTMCU3, the behavior has been changed a bit. From these versions, you will see CxConsumer wait if the consumer thread is waiting for the data to be available. And this is supposed to be a harmless wait because in that case consumer thread cannot do anything, and it is waiting for the producer thread to bring the data into the buffer so that it can further process it. So it is supposed to be a harmless wait, but if you see too many CxConsumer wait types, then you still need to investigate that, and if it is a problem, you need to troubleshoot it. But in most of the scenarios, this wait type is harmless. Okay, now from SQL Server 2022 and also in SQL Server Azure, you have two new wait types which are CxSync underscore port and CxSync underscore consumer. CxSync underscore port wait you will see when it is waiting to open, close and synchronizing exchange iterator port between producer and consumer thread. And CxSync underscore consumer wait you will see when exchange iterator is waiting to reach the synchronization point. Now, you will not understand much with this definition, but I will cover CxSync underscore port wait a bit in my demo. There you will have more idea about it, but there is not much data available on CxSync underscore consumer wait yet. So I will not be able to cover this wait type in this video, but as soon as I will have much information on this wait type, I will create a separate video and upload it. Okay, so let's go to the demo and try to understand when and where we will see CxPacket or CxConsumer wait. Okay, I have a select query here. Then I have another select query here which is using couple of DMVs which are OS workers, OS tasks and OS threads. So this select statement will actually give me the information related to task, workers and thread, and as I have the where clause on session ID 52, so it will return only the data which is relevant for session ID 52, and this is the session ID 52 as you can see the SP ID here. So let me go ahead and execute this query. Okay, and then I also want to run this select statement when this select is running, and you can see total number of 5 rows here, and these are actually 5 threads, and for one of the thread parent task address is null, and this is the controller thread, and for controller thread parent task address will always be null. Now I have total 4 CPUs in my laptop, and you can see that all the schedulers are in use for this select statement. You can see scheduler ID 0, 1, 2 and 3. The controller thread has reused one of the scheduler, which is scheduler ID 1. Sorry, the scheduler ID 2. But the controller thread is not all the time restricted by MAXDOP setting, and if you have extra scheduler available, sometimes you may see that your controller thread is using an extra scheduler. So actually let me go back and use this MAXDOP hint, and I'm gonna run this statement with MAXDOP 3, and this time I should see total number of 4 threads, because MAXDOP is 3 and parallelism operator can use total 3 threads, and then there will be one extra thread which will be the controller thread. And in this scenario these were 5 threads, because one of the there was one controller thread, and then as MAXDOP was virtually 4, because I have maximum number of 4 CPUs available in my laptop. So it has created 4 threads to actually scan the data, and then there was one more thread for the controller thread. Now for MAXDOP 3, there should be 3 threads to actually scan the data, and then one more thread which will be the controller thread. So let me go ahead and see if this theory is correct or not. So I have executed the query. The result is not started yet, but let me actually go ahead and execute this select statement. And this time you can see there are total 4 threads, and one of the thread is the controller thread, which has the parent task address as null, and then there are 3 more threads. So MAXDOP is 3, parallelism is using 3 threads, and then one more controller thread, which completely makes sense. Similarly, let this query complete, and I will run this query with MAXDOP 2 also. But for MAXDOP 3, one thing that you would have noticed by now is that total number of 3 schedulers have been used for this select statement. The scheduler ID 1, 2 and 3, and then the scheduler ID 2 has been reused. However, I have one more scheduler, which is scheduler ID 0, and controller thread sometimes can use that extra scheduler, but in this case it is not doing this. Now let me go ahead and change this MAXDOP query hint to 2, execute this again, and let me go back to this select statement, and I'm gonna run this select statement again for MAXDOP 2, and this time you will see a total number of 3 threads. So let me go ahead and execute this, and yes, you can see 3 threads, because MAXDOP is 2, parallelism is using 2 threads, and then there is one more controller thread, and also you can see there are 2 schedulers that has been used for the threads that parallelism operator is using, but for controller thread it has gone and used one extra scheduler because it was available, and as I've already told you that the controller thread may use the extra scheduler, but this is not always true. Sometimes even when the extra schedulers are available on the machine, but it will still go and reuse one of the scheduler. So this is fine. Controller thread is not restricted, that's it. But your other threads, which are actually responsible for all the data scan, have been restricted by the MAXDOP setting, and it is using only 2 schedulers. Now if you have understood how it generates the threads and how exactly it uses the scheduler ID and how exactly it is dependent on MAXDOP, then I will go to this select statement here, and you can see I'm using sys.sysProcess table and recording SPID, KPID, blocked wait time and last wait type, and I'm running this in infinite loop here, because you can see a while 1 is equals to 1, and this is the infinite loop, and my purpose is I will execute this query first, then I will run my select statement, and I will try to capture all the different waits that my select statement will encounter in the entire duration. So let me actually go ahead and execute this, and actually let me go ahead and comment this out and execute this as well. And once the query will complete, we will look at the output. Because I am recording the output, I am inserting the output of this select statement into a table which is weights table. And once the select query is complete, I will go ahead and kill this statement, because this is running in infinite loop. This is not gonna finish on its own. So I will have to kill it, and then I will run this select statement here, and it will show me the output that this query has generated. And there we can see different weights that my select statement has encountered in the entire duration. Okay, so it is already running for more than 40 seconds now. So it should not take more than 10-15 seconds. It is taking more time because there are other queries also running on this system. But that's okay, it is completed. So I will go ahead and kill this, go back, run the select statement, and you can see lots of different weights here. So initially you can see the different iterations. You can see there were only one thread because the query actually did not go to the parallelism yet. But after a certain time, you will start seeing that there are multiple threads for the iterations. Like for 3935, you can see 6, 7, 8, 9, 10, 11, and 12. Total 7. And similarly, if you will go down further, you will actually see more threads for the single iterations. And for 3938, as you can see, there are total 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sorry, 9. Right? So you can see total number of 9 threads here for this select statement. Okay, so now I have maximum 4 CPUs. The MAXDOP is 0. Why exactly I see total 9 threads here? So for this I will have to go to the execution plan, and if you look at the execution plan, initially these two parallelism operators were running together, and it was running in parallel, and each parallelism operator was using 4 threads. So it makes it to 4 plus 4, 8 threads, and then there was one more controller thread, and this is why you see total number of 9 threads. But once this part will complete and this part will start to run, there is only one parallelism operator, and here you should see only 5 threads. So if I'll go down further, let me come here, and if you will look at any iteration now, like this one, so you can see total number of 5 threads that has been used. Even if you look at the next iteration or the next to that as well, there are always 5 threads, and this is because these threads are coming because of this parallelism operator, and MAXDOP is virtually 4 because I have total 4 CPUs available. So it has generated 4 threads, and there was one more thread which is controller thread, right? So now if you have understood this, how exactly it generates the number of threads that you see for your query, and how exactly it use the schedulers, then I want you to look at the property of this select statement. I mean the property of this select, and here at the down you can see weight stats. I want to expand these weight stats one by one, and top weight that you can see here is CxPacket. The second top is ASIC network IO. The third top is CxSync_port. The fourth top is SOS scheduler read. Then there are other, but the wait time is already very less here, so I am not interested in the other weights. Let me close this, and now let me go to the very top, and I will see what are the different weights that I can see here. So initially I have seen memory allocation, I have seen SOS scheduler yield, but then I have seen too many CxSync_port weight, I have seen couple of CxConsumer weight. But if I'll go down further, I will start to see more and more CxPacket weights, and if I'll go down, then I will start to see lots of ASIC network IO weights, and the wait time is actually used for ASIC network IO, and this is why it was at the second spot on when you were checking the weight, different weights for this select statement. So if you go down, you will see more and more ASIC network IO weights, right? So I'm gonna cover this weight after the next video. In the next video, I will cover how exactly you can troubleshoot CxPacket or CxConsumer weight. The next video will be on async network IO, and I will come back and run this select statement. There we will discuss why do you see this async network IO weight and how exactly you can troubleshoot this. But for now, as we are discussing CxPacket, CxConsumer are the two new weights which are CxSync underscore ports and CxSync and underscore consumer weight. So let me go ahead and discuss those first. So initially you see a CxSync underscore port weight here because of this sort operator. This sort operator will first gather all the data and then process it further because it has to sort all the data first. So for this you see CxSync underscore port weight, and whenever you see too many CxSync underscore port, you should always look for this kind of sort operators before parallelism, and if this sort operator is costly, then you may see CxSync underscore port wait time will increase gradually. So if I look at my select statement, I have order by on transaction ID, but if I increase the number of columns in my order by clause, it will make the sort even more costlier, and in those cases also you may see CxSync underscore wait underscore port wait time is growing further, right? So whenever you see CxSync underscore port, mainly look for this kind of sort operators. I'm still gathering more information on this particular weight, but I've particularly seen this weight type for this kind of sort operators, so I thought to cover it. But I will soon gather more information on CxSync underscore port and CxSync underscore consumer weights, which are new weights in SQL Server 2022 and SQL Azure, and I will create a new video on this. But for now, let me discuss further the CX consumer and CxPacket weights. So you see CxPacket weight because your query is running with parallelism and you have multiple threads. Now your controller thread will always show CxPacket weight. So no matter what, CxPacket weight has to be there if a query is running with the parallelism operators. Now there are many child threads, and if one of the thread is completed and it is just waiting for the other child thread to complete, it will also show CxPacket wait, and this is why you will see too many CxPacket wait for this select statement. Now you also see CxConsumer wait, and CxConsumer wait is coming because the consumer thread is waiting for the data to be available, and this is considered to be harmless wait because consumer has no data to process, and this is not the problem. The actual problem is somewhere else. Why this data is not available? Maybe the one of the producer thread is lagging. Maybe one of the producer thread has been blocked. Maybe one of the producer thread is still performing the physical IOs and it is showing page IO latch wait for your statement also. So in those cases, your producer thread may delay, your buffer is full, the problem with the buffer may also cause this kind of problems. So, but the problem is not exactly the CxConsumer wait. So you will see CxPacket wait along with this and many other waits, like if you see lock wait, then you may have to investigate that. If you see page IO latch, then maybe you are performing too many IOs or there is some problem with your disk subsystem. I will cover these weights actually in detail in the upcoming videos, but for now I'll just give a little idea about this. So if these kind of things are happening, CxConsumer weight will come because there is no data for the consumer thread to process, and it will have to wait. But the problem is somewhere else, right? But if you still see too many CxConsumer weight, which is not the case for my select statement because it was not among the top weights for the selected query, right? We have already seen the top weight stats for the select statement and it was not there. So we don't have to bother about it. What we need to bother about is I had lots of CxPacket weight and then I had lots of async network IO weight. And if we have to bother about CxPacket weight, then we'll have to troubleshoot that as well. And this is what I'm going to cover in my next video, where I will execute few queries where you will see CxPacket wait, and then I will discuss few of the ways you can reduce this kind of weights, and I will actually also discuss if you see CxPacket wait and you have some problem, actually you should bother about CxPacket wait or not. In what scenarios you have to troubleshoot it. because controller thread will always show CxPacket wait. Then the child thread will also show CxPacket wait if they have completed early. So this has to be there. You cannot, just hide from the CxPacket wait completely. But when exactly you have to troubleshoot this will be part of the next video. So I will see you again in my next video. Till then, thank you for watching this video.